Welcome back, episode 3, Mr. T here. We left off partway through our script here. We were making our golf ball controller. We had set up all of our checks within the update, so everything we need in the update is done. We still have to create our methods, so when we click on the ball, we start aiming. When we hold it down, we are aiming, and then when we release the left mouse button, we will shoot the ball. So we're going to code those in, but first, now that we've saved this script, we're going to go back into Unity, and we're going to go down to this script, and we're going to reference these. The rigid body is easy. We're going to just click that, drag down, and reference the rigid body there. And we're going to need to add this line renderer. We don't have it yet. So we're going to go add component, start to type in line renderer. You'll see it right there. And we're going to reference that line renderer like so. Okay, now we're going to be tweaking this line renderer later on. We won't be able to see anything yet on our, like if we zoom in on our ball, we can't see any line yet being rendered, but we'll work on that afterwards. But I just wanted to get that set up first, and then we'll play around with what the line renderer actually looks like in game. So let's get back to our script here, and we're going to be first working on the start aiming method. This one's pretty quick and easy. So what we're going to be setting up is we're going to take the current power, and we're going to set that to 0. Basically resetting the power from the previous shot taken. Next, we're going to be taking our line renderer and we're going to be enabling it. We're going to be turning it on. Okay, because you won't always see this line renderer. We only want to turn it on when we start aiming, and we are currently aiming. So we're going to turn that on by saying true. And next thing is we're going to store the start shot position. So that's going to be equaling the input dot mouse position. Now that's going to be storing the mouse position on the screen. So just keep in mind why we need to be converting. How this works when we're in our game is that when we click on this screen, how this works is down here at the lower left, this is location 0, 0, and it's an XY coordinate. There is the Z value is set to 0. So we need to convert that, because where I click here, because this is 3D, won't convert into my 3D space properly. So let's get back into this, and we're going to be using that position in the next part. So start aiming, that's done. That's all we need to do in there. In the aim function, though, we got to do quite a bit. First, we're going to calculate the power based on where we move the mouse position. So remember, this is while we're holding the left mouse button. So we're going to be creating a quick vector 3 within this method, and that's going to be called the mouse screen position. Okay. And we're going to set that equal to the input mouse position. So we're going to be using that wherever we move our mouse while holding it on our screen. So that's going to be storing that. And then we're going to need another extra float. We're going to be calling this distance. So this also is a float we're creating just in this method. In this distance, we're going to be calculating from the start position to the mouse screen position. So this is going to be we're going to be accessing a vector3 dot distance method. So we're going to find the distance between two spots, and you can see it's autofilling. It knows exactly what I want it to do. I want it to find the distance between the start shot position and the mouse screen position. Okay, once we have that distance, we're going to create our power. So we're going to update our power finally. So we're going to take current power, and we're going to set that equal to, and here what we're going to be using is another mathf, and we're going to be clamping it in between two values, because we don't want to be able to hit this as hard as we want. It would get a little crazy, or as little. We want to clamp it in between two values. So we're going to use math dot clamp here. And the way math.clamp works, we can see it here. I'll show you with my mouse. We want to enter in a float value that we start, and then we have a float min and a float max. Okay, so this value, it's going to make sure that whatever this is, it stays between these two values. So first, let's calculate that value. And how we're going to be doing that is it's going to be equal to the distance. Okay, and we're going to be multiplying it by that weird screen world conversion factor that we set up before. Okay, we're also going to multiply it by max power. We want to multiply by max power, so that's going to be controlling exactly how hard we hit this ball. Now, it already knows what I want it to do. I want to stay between the float of 0 and max power. So I don't want to go outside of those values, and everything should work just fine. I think I just got to put an F after that 0 because this is a float. And there we go. That first part, that's going to calculate the power. We haven't moved the ball at all, but that's just calculating power based on mouse position. Okay, so that's now converted. Okay, now let's actually calculate the direction, and this is based on the camera and mouse position on the screen. So we're going to be creating, again, a vector 3 inside this method. We're going to call this screen direction. So this is going to store the screen direction on that XY plane I talked about. And that's going to be equal to our mouse screen position, and we're just going to be subtracting the start shot position. So that's going to get our screen direction. When you subtract two vectors, you'll get the direction between the two of them. Okay, and I'll show that in class in a little bit more detail. Now we can actually create our shot direction. Now the shot direction is what's actually happening in the 3D space. So this is going to be a new vector 3. And this is going to look a bit weird, but what we're going to be accessing is the screen direction, screen-direction.x. I want that screen direction in the XY plane. The X doesn't change. That's perfectly fine. The Y, of course, I need that to be 0 because in 3D space, Y is up and down. So I don't want to be shooting the ball into the air. I'm not shooting it up. I'm shooting it in the XZ plane. So this is where I'm going to basically convert an XY screen position into an XYZ in world vector 3 direction. So that's why I'm going to be using screen direction dot Y. Okay, so now that's going to be my 3D. That's the direction I want the ball to. Oh, this is where the direction of the renderer, the ball is going to go in the opposite direction when we apply the force. Okay. Also on here, we're going to be, later on, we're going to be controlling our camera. So we're going to use this, we need to tweak this shot direction to match our camera. Now this is going to be moving with angles, and it can rotate on the axis for our camera. So just please type this in the same way. So we're using quaternion, so that's going to be controlling an angle axis. Okay, and that angle axis that we're going to be tweaking is the Y. Okay, so I'll show you how we actually set this up. So we're going to be accessing the camera again, .main, so that's our main camera in currently. We're going to access its transform, and specifically we want the Euler, which is in degrees, so Euler angles, and I want that for the Y value. So that's going to return whatever the current Y angle is. So this is going to make sure we shoot when we are shooting, it's going to set up our line renderer in the correct direction, even if the camera has been rotated. Okay, and what else do I need here? Oh, so then I'm going to need the default for the axis, which is vector 3 dot up. Okay, so that's going to return a vector of 0, 1, 0. So we're going to take all of that, close it in some brackets, and of course multiply it by the shot direction. Okay, so now that basically, that big long line of code, make sure when the camera has turned that our direction will be correct. Okay, now some games you might not want to be moving your camera around, but you're going to see in this one, it's a great feature to have. That shot direction. Now, when we get a direction, we often, what we want to do is normalize that. So to do that, we're going to take the shot direction and normalize that. All that's going to do is create a magnitude of 1. So we're just using that as a direction, not a magnitude or the strength in which we're hitting. We just want the direction. So it has a magnitude of 1. That's what normalize means. Okay, big thing in this aim. It's definitely got the most in it. Now I want to actually draw this line renderer. So I'm going to access the line renderer, and first I'm going to be setting its first position. This line renderer has 2 positions by default, so I'm going to go set position, and I'm going to access the first one, which is the index of 0, and that first one's going to be the transform dot position of our golf ball. Okay, so that's going to be starting to draw wherever our golf ball is. And then we're going to be doing the same thing, line render dot set position, but this time we're going to be accessing the second point, or where is this going to be drawn, and this is where we're going to use transform dot position again, plus, because we want to go from there in the direction, so we're going to add on shot direction. We're going to multiply that by current power. And we're also, I found I needed to tweak this a little bit when I prototyped it by 0.2, okay? Because it was drawing the line way too big. So this is going to make it 20% by multiplying it by 0.2 in its length, which is a nice conversion. It looks a lot better on screen. Okay, so that's it for the aim. So what's happening here? First, we are basically, as we're holding down the left mouse button, it is storing the start position where I click the ball. It's getting that direction where I move on my screen. It then converts it here with into 3D space. That's this part here. Then it converts the angle so that it's in the right direction based off the camera. It's normalized to a magnitude of 1 so that it can be used here. We're going to use shot direction again in shoot, but it can be utilized here to make sure that it is not a huge magnitude. It's just a magnitude of 1. Current power is what's controlling the magnitude or the length of our actual line going from position in this shot direction. All right, let's get the shot done so we can actually see what this looks like. First thing first, we're going to be we're going to add the force. So right away, we're going to apply the force, but in the opposite direction of this line render. So we're going to go rb.addForce. And what we're going to be doing here is the add force, we need a vector 3 to put into here. So we're going to do the negative, so make sure you put that in or else your ball's going to shoot backwards, negative of the shot direction, because we want to go the opposite direction of the line render because we're pulling back to shoot. You'll see that in a second. We're going to multiply that, of course, by current power. And the force mode we want is actually impulse. We want to apply this right away. So we're going to add on a force mode, and we're going to use impulse on this one. Okay, that's going to finally shoot our ball. Yay, it's going to go somewhere. After we shoot this, we are, of course, not stopped anymore. So we're going to change the is stopped to false. It is going to be flying through our golf hole, through our level at that point. Also, after we shoot this, we're going to reset the current power. We're going to reset that back to 0 so we can use it again for our next shot. And we also want to turn off our line renderer again, so we don't want to have that still on our screen. So we're going to line renderer enabled, and we're going to set that equal to false. So that's going to turn off our line renderer. Also, this is a great spot. We're going to just pop this in here right now, shots taken, and we're going to go plus plus, and what that does is it takes whatever value it is and adds 1. So that's a short way to code that. The long way would be shots taken equals shots taken plus 1, but shots taken plus plus is way faster. Okay, let's save this and see what it actually looks like finally. We're going to have to tweak a couple things with the line render, but let's go back into Unity here. And let's see if we can actually click on this ball and take a shot. Let's make sure, yep, everything's saved there. Let's press play. I'm going to click on this ball. We don't see a line right now, but it is shooting our ball. Okay, so we see it moving around here, comes to a stop. We don't see the line renderer yet, so let's fix that. Okay, so Let's go down to our line renderer here. What we're missing is a material. We don't have any material here right now. So I'm just going to quickly make another material for that. So right click, we're going to create a new material. And we're going to call this line. I'll do underscore again, same formatting as I've done before, line mat. And the line mat here, we're going to tweak a couple things on this material. First, what I want you to do is I want you to switch this, to transparent. Okay, once you switch that to transparent, we can go ahead and we can tweak this color here. But actually, a better way to do it is we're going to go and apply this to our ball. We're going to take the line mat, we're going to apply it here, and then I can go into color here and we can actually do what we've done before. We can set a couple colors to blend between here and change the transparency. So I'm just going to set the far left. Let's go with, I think when I've done this before, yellow's going to look not so good. So green will. So let's start with yellow, and then at the other end here, I'm going to blend it to a red. Okay. I'm going to leave my transparency as is, but feel free to tweak that if you want. So now that's set up. And now when I press play, we should be able to finally see our line render. Okay, so this line right now, it's not showing up the colors properly. I'm going to tweak that in a second, but we can actually see the direction that we're shooting in. What we do need to do is we're going to be tweaking the width because it's just a solid line. So right now I'm going to go over to my width here. I'm going to click on here, double click, and I can drag this down. So it's going to change the width from one point to the next point. And I actually like to make this one a little bit smaller, but you can play around with this. You can customize how this is going to look for you. The line mat, transparent, it's not showing the colors yet. Oh, right, so we're going to change the shader here. We don't want it on the universal render. We're going to go down on our shaders and we're going to choose particles, standard unlit, and then set that to transparent. There we go. That should work now. Okay, so let's test this out. Click on my ball, and there we go. We have some colors. It should go through the wall. We have it now. So now I can fire the ball around my hole, and I can shoot little tiny shots here. I can shoot small shots. You notice that it does stop when it gets close to being fully, when its magnitude right hits 1. And I can fire this around and shoot. You're going to notice a problem though, and I'm going to try to make this happen as best I can. Let's see if I can do this. You're going to notice it's not bouncing properly, and I know one way that I can show it. What's happening is the rotation is affecting it. So you think if I shot this at an angle, it should bounce off. It should run. It didn't do it that time. Oh, see, just did it there. Because of the spin on the ball, and we do want the ball to spin, but the spin is affecting how it bounces. And we actually want to turn that off because when you're trying to aim your angles, and you saw it bounced in the air there too, we don't want that. It won't be bouncing the way we want it to in the proper angles. You can see right there, it didn't bounce in, it didn't reflect off properly. So we're going to play around with that in the next video. That was a really long one, so I hope your script works. I hope you can shoot your ball around the game now, and we're going to be doing a few tweaks in episode 4. See you next time.